Hello there, I'm Thomas Hatsios, the pilot captain flying the Boeing 777-300 ERX into Dutch flight from Zurich to the Düsseldorf airport. We're going to be overflying Switzerland, Germany, and then coming back to Switzerland, Zurich International Airport, runway 14 for ILS localizer landing. So right now I'm in the cockpit of the Boeing 777-300 ERX airplane. So I'm going to start showing you the systems and the displays of this airplane. So I'm gonna start with the primary flight display. I will show you the airspeed indicator and the airspeed selected from the autopilot and flight director system, the barometric altitude above the sea level, and the altitude selected from the autopilot and flight director system. I'm gonna show you the vertical rate of climb and descent of the aircraft tape. I'm gonna show you the barometric altitude above the sea level. I'm gonna show you the magnetic and true heading compass, magnetic north pole, and the true north pole. We have the magnetic variation depending on where we are in the world. So we also have the attitude indicator. We have the flight director crossbar and the pitch ladder and the bank angle in degrees. So we also have the takeoff speeds and the speed limits, the airspeed limits tape, and the angle of attack of the aircraft. And we also have the autopilot and the flight director command bar, the ILS localizer command bar, the radio altitude above the ground level, and the flight mode annunciator with the auto throttle and the autopilot command mode for vertical and horizontal navigation. So you can see here the primary flight display that I'm telling you. You can see the airspeed here, the altitude, the rate of climb and descent, the other modes I'm gonna talk to you later. This is the navigation display. This is the autopilot and flight director system panel. Over here, all the switches. This is the ACAS, the upper ACAS, the lower ACAS, the flight management computers, the thrust levers, the flight controls here, and the overhead panel with the systems. So besides the primary flight display, we have the navigation display. That displays all the airports, the waypoints, the VOS stations, the nav aids, like the ADS and the NDB. So we also have the airports with the airport that we are located right now, the runways, the takeoff runway, the arrival runway, and the intermediate waypoints we create using the flight management computers for navigating the aircraft vertically and horizontally in the flight path that we create, flight plan that is displayed with magenta line on the navigation display. And the aircraft can follow using the autopilot and flight director and also the auto throttle command. So you can fly this flight plan automatically, or you can fly it manually using your own input in the flight controls and the thrust levers. So I'm gonna show you these systems also. We also have the terrain reflections from the weather radar, and we also have other aircraft flying around us. We have the magnetic and true heading, also the ground speed, and the wind speed and component, and the next waypoint we're gonna be flying over displayed here. So you can see the track and heading here. Uh, besides the primary flight display, the navigation display. So we have also the autopilot and flight director system panel. Uh, we have the autopilot engage and disengage switches. We have the airspeed select knob, the airspeed select knob, and also uh, the auto throttle arm and disarm switches for the left and right auto throttle system, and the airspeed select knob and the airspeed select modes. We have the fixed thrust mode for the engine when we glide, and we have the variable thrust from the engines when we cruise and when we approach for landing. When we select the airspeed and engage the auto throttle system, so we have two modes for climb or descent. We have maximum climb, for instance, and one limit climb with fixed thrust takeoff, and then climb to the cruise level. And uh, this varies the airspeed as we climb, and we have fixed thrust by varying the rate of climb and descent, the angle the aircraft climbs or descends. So when we fly in a straight level, we vary the angle the aircraft flies. So we vary also uh, we vary the airspeed and the thrust from the engine. So we don't have fixed thrust, we have variable thrust. Also for approach and landing. So we try to maintain a constant pitch attitude, not vary the pitch attitude of the aircraft. So we vary only the thrust commanded. So you can see here this is the primary flight display. You can see here the navigation display, the autopilot. You can see the airspeed here selected. So besides that, we have also the autopilot engage and disengage switches. We have the flight level change, the auto throttle hold switch, and the glide continuous for the airspeed select. We have the bank angle limit and the heading select knob, and also the heading hold switch. We have the vertical rate of climb and descent, and also the flight path angle rate of climb or descent of the aircraft. This is the autopilot flight director system again, and the hold switch for this mode, and also the altitude select and the altitude hold switch. We have the bore localizer switch and the approach for auto land switch, and also the flight directors for the first officer and the captain. So you can see this here also in the autopilot flight director system. Here's the operators. You can see the engine limits and some factors here. So I will start showing you the primary flight display first. So you can see here in the primary flight display, as I told you, we have the airspeed here. The airspeed selected displayed with purple color. The altitude, the barometric altitude above the sea level. You can see here 1,430 feet and the barometric pressure setting. For this atmosphere we are located right now in this server. You can use this switches to set over here the barometric pressure. So we have also the radio altitude above the ground level, the vertical rate of climb and descent needle here, the altitude select from the autopilot and flight director system. The flight director, you can see the crossbars here for the Lszh localizer or other modes like the autopilot mode, vertical and horizontal navigation. So you can see the V speeds here as it's gonna take off. The airspeed is gonna increase. So right now our ground speed is 0. We also have the heading, the magnetic and true also here. You can see the altitude here, the pitch altitude in degrees, 2.5, 5, 7.5, 10 degrees here. and also for the bank angle limit. So we have climb in the blue and descend the in the orange color. So here's the navigation display. You can see the airports, the waypoints, you can see the weather radar and the terrain radar. You can see the reflections from the ground. This ground level 6,100 feet maximum displayed with red. Where is the Swiss Alps? Over here is the Switzerland. You can see the 0 feet displayed with green. Also magnetic control heading. We have some other aircraft flying around us. Here's the flight mode annunciator with the takeoff go around right now. So I will show you a couple more things like that. So we have like a few more minutes left to go. So I will show you now the navigation display. You can see the terrain radar, the scan here, the beam. So you can see the terrain and weather radar is over here. This switches, we can turn on and off and select the modes. This is the transponder for showing you other aircraft. I will talk to you. It also shows our position to the other aircraft and the air traffic control. So I'll talk to you in another slide. You can see the extra stuff. You can see the autopilot and flight director system panel here. After the primary flight display and the flight mode annunciator and the navigation display, now I'm going to show you the autopilot and flight director system. So you can see here we have the autopilot engage and the autopilot disengage switches. We have the airspeed select, so we can select a higher airspeed here, just for takeoff or for flight or whatever. Select indicated airspeed or Mach. Some modes like flight level change. So you will see the flight level change speed displayed now over here, and the airspeed selected over here. Airspeed selected and altitude selected here, 10,000 feet. The angle of attack of the aircraft, it's 0 right now. So if we select a couple, maybe other modes here, we can select the heading here, climb continuous, the auto throttle left and right, on and off. You can see the ATR, the auto throttle, indicated airspeed, Mach. Some of the climb continues, the auto throttle, and the LNAV and the VNAV. Here we have we will select a different heading just for the takeoff, the runway heading. We can deselect like this, select another. This also is depressible. We have heading or track here. Now we have track, now we have heading over here. So we can select different altitude, like first select the thousands, then the hundreds, and then press the hold and also the heading hold. We have also the vertical rate of climb and descent here, this area. So you can see also these here. You can see the zeros, you can see the cursor and the slider. So now it's positive, before it was negative, so it can be more than that. So you set the rate of climb, of descent, and also the flight path angle, one of the two. So you will see here some things engaged right now. It's the vertical speed, the heading, hold, the same modes, the rest are the same. And you also see here's this symbol represents the 3,900 feet per minute that we want to climb or descend over here, plus 3,900. We can turn this in the flight path angle. select minus or a plus, like plus 3.5 over here. So now we have the flight path angle instead. So the flight path angle is, I think, is represented with this symbol, this purple marker over here, the FPA. These two crossbars. So we have the flight director and the flight path angle. We also have the heading here, 136 degrees heading. So there's a few things you can do with that. Now we have the altitude. So you will select another mode now, the altitude and the heading, and we can select the autopilot on, like that. If we set the flaps down for takeoff over here, so we have to set the flaps down to engage the autopilot. I believe this is some inhibition, so you can see our airplane, the Boeing 777. I'm gonna show you how to start the engines in a while, in like a couple of 10 minutes maybe. So we have a couple more things like the autopilot engage and disengage. We have the flight director here, on and off this switch, you can see. Also the autopilot now is engaged. So you see the autopilot flight director. Here is the autopilot command. You can use here's the control wheel, so you can use this switch here to disengage the autopilot. You see the autopilot disengage here, autopilot disconnect, and we have this warning. We need to cancel here. The autopilot disconnect, reconnect this. We can disengage it now like this, using this switch here, like this again. So you will see this disengages the autopilot. So you will see the warning here, autopilot disconnect. So you cancel this and reset the system. Now we can continue with the other system. I will show you now how to use the thrust levers to increase the engine thrust for takeoff, or decrease it for descent when flying, or actuate it when flying level, or for approach and landing. I'm gonna show you also the flight control system of this airplane, how to use the flight controls for flying the aircraft in flight. So I'm gonna start maybe showing you the thrust levers here. You can see the flight controls here. You can see we have the rudder pedals for the vertical stabilizer rudder. So we have a couple things. We have the speed brakes here, the speed brake lever. We have the flap lever I told you. We have the horizontal stabilizer trim. This lever here also use this switch here in the control wheel. We have the ailerons, same position also. We have the vertical stabilizer rudder here trim, the rudder trim. This for the flight controls, and the aileron trim. So this is the radio and communication panel. This is the fire extinguishers for the left and the right engine. I told you this is for the horizontal stabilizer, the horizontal tail of the aircraft. This is the desired trim position, nose down or nose up. You will see nose down or nose up. This is the parking brake. So you can see now nose up and nose down. Also here nose down and nose up for the airplane when it's flying. So this balances the aircraft in flight. So we have this here. I will show you. This is the thrust levers. If I advance the thrust levers, the speed brakes will retract automatically. So you will see here the engine indication. This is the N1, the low speed, low pressure compression stage of the engine. The engine limit for flying the aircraft. We have the exhaust gas temperature, the duct pressure from the engines. This is the outflow valve, duct pressure, the coming out. This is the cabin pressurization system. Here, the landing gear down and up, the flaps position, the total fuel on board, and the temperature of the fuel, which is 104,000 pounds. The N2, the high pressure, high speed rotor stage of the turbofan and the fuel flow per engine per hour, the oil pressure, temperature, quality, and vibration of the N2 stage of the turbofan turbojet engines of this Boeing 777-300 airplane. So you can see we increase the thrust like that, we decrease it like that. I will talk to you now about this. So we also have a couple of buttons here. We have the auto throttle. This disconnects the auto throttle here in flight, pressing this switch, and you have the auto throttle disconnect. We also have the takeoff go around button. We have the thrust reverse here, which also engages the speed brake. So you will see the thrust reverse here, displayed in the upper ACAS engine indication and crawler system. If I come in the outside view, you will see here the thrust reverse is being engaged for this airplane. So you can see the thrust reverse here, the blocker doors open and reverse the flow for slowing down the aircraft after touchdown. This is a nice representation of the system. So you can disarm, you can close the thrust reverse, you can open it again, whatever you like. Not do that in flying when the aircraft is airborne. So close it again, the thrust reverse, and open it again. So this is the thrust reverse. So I will show you a couple of the flight controls now, and then make an engine start demonstration. So we also have, I told you, the stabilizer trim position here, this section. So you have the electric trim from the CNVR hydraulic system. This is the electric trim for the flight control computers and the autopilot and the flight director and the auto throttle. We have automatic trims, so you have the normal and the cutout switch position. So you leave it. You can see the CNVR, the stabilizer of the horizontal tail. So when we advance the thrust levers forward, when we are in the ground, we need to increase the thrust from the engines in order to start moving the aircraft. Then we need to take off from the runway. So for this aircraft, with this weight, right now it's 254,000 kilograms, I think. So it has about 46,000 kilograms of fuel on board and about 20,000 kilograms of passengers and cargo. In total it's 254,000, I think. So it needs a takeoff speed of about 154 knots, or about 270 kilometers an hour. That's for takeoff. So when you advance the thrust levers, you increase the thrust from the engine, you increase the fuel flow and the air intake rate of compressed air into the compressor of the engines, the high pressure compressor and the burning stages of the engines. So of the turbofan engine. So you increase He increased the fuel burn and the expansion of burning gases, which generates the propulsion of the aircraft forward, which gives this aircraft by means of action and reaction using the Newton's first, second, and third law of motion of kinematics, the Newton's physics, and also aeronautical engineering principles and aerodynamics. This makes the aircraft acquire kinetic energy, which is 1 second the mass of the aircraft times its velocity times to the power of 2, which makes it moving forward, and then you can accelerate in the runway, reach the takeoff speed, which is about 270 kilometers an hour. As I told you, 154 knots. It should be higher than the stall speed of the aircraft, because the stall speed won't generate a lift enough to make the aircraft flyable, will make it fall down to the ground again. So this lift component will overcome the weight of the aircraft times, which is equal to the acceleration of the gravity times the mass of the aircraft. So you generate a lift component equivalent to the angle of attack of the aircraft when it's taking off, which is about 10 to 12 degrees of pitch up, nose up, pitch up, and also you should be careful not to exceed the pitch altitude in takeoff, so you won't strike the tail. Also in landing it's the same principle, but you can use higher airspeed for landing. So it's a few more principles about the flight controls of the aircraft. You generate lift, you just generate thrust and forward movement using the thrust from the engine. You generate the lift over here in the wings, in the forward wings, which also support the main load of the airplane. The weight of the aircraft is divided over the surface area of these wings. So you have the weight divided by the lift component, for instance. So the lift is the force that makes the aircraft go up into the air, using its wings surface, which as you can see, the bottom surface is a little bit more flat. This is the principle from aeronautical engineering and aerodynamics, while the top surface should be a lot more curved. It has a higher curvature when you fly, and the leading edge, the angle of attack should be having this curvature above, going above the wing. So if this happens like that, while you have a flatter surface in the bottom, you have more pressure in the bottom, because the air travels slower in the bottom surface of the wing, and it travels faster in the top surface of the wing. So the airspeed difference of the air mass as the aircraft flying is higher above the wing, and it's slower below the wing. You have higher pressure below the wing. You have air accumulated below the wing, which makes the air pressurized below the wing, and you have air lower pressure above the wing. You have low pressure over here, which makes an air suction above the wing that sucks the air up in the aircraft up into the air, the aircraft weight. You have an air vacuum above the wing created. So you have an air pressure, so you have a differential pressure between the bottom and the top surface of the wing. This creates the lift force that overcomes the weight of the aircraft times, which is equal to the acceleration of gravity times the mass of the aircraft. So this is Newton's physics again and kinematics. So you also use the Bernoulli principle for this, for the airflow and the acceleration of the gases. You also have the acceleration of the gases here, as you can see, from the engines moving forward from the exhaust all the way back. You can see this flow of air that moves the aircraft forward. You can see how this airfoil looks like. So you also have you can use this wings to create lift. You can use them also for flying, for having directional control by installing some flight controls over the wings, like the aileron and the spoilers, and also having a horizontal stabilizer tail and a vertical stabilizer tail with this aircraft. So as you can see, this creates a moment arm force. The horizontal tail. The horizontal tail of the aircraft has its horizontal tail stabilizer position. When you fly, you can actuate it up and down, nose up and nose down, using the stabilizer trim position. You can also use the elevator for pitching up, for climbing the aircraft, and also pitching down for descending the aircraft. You can also use the directional left and right yaw from the rudder, from the vertical stabilizer, and also the other from the spoilers for bound rolling left and right. So this creates the directional control of the aircraft. As you can see, all these forces are vectored through the center of gravity of the aircraft. So all this creates, when you deflect the flight control surface, as the aircraft is flying, you have an effective airspeed of around 270 kilometers an hour or higher. So you have enough lift component. You have effective lift for flying the aircraft. You have also direction. You have effective flight controls. You can move the elevator and the rudder, so you can deflect the airflow of the air mass as you fly and make the airplane yaw or pitch up and pitch down around the center of gravity. And also, this is vectored. All these forces are vectored. So you create a moment arm. The moment arm is for this situation is time. It's the air mass of the airflow per second times the surface area of the horizontal tail elevator or the vertical tail elevator or the other spoiler. Um, and it's times the distance from the center of gravity, and it's also times the gravity acceleration. So it creates a force using the Newton's physics again and aerodynamics and aeronautical engineering. So you can see here this force component, the elevator picks up, picks down, the rudder left and right. You can see here is the center of aerodynamic pressure here, and the center of gravity is located about the same point. This creates the moments around the aircraft as you fly, so you can have directional control like that. So I'm using, as you can see, I'm using this side stick for flying this airplane. So you can see here, pitch up and pitch down, bang roll left and right, and also the yaw, the rudder pedals. So I'm having directional control here. As you can see, pitch up, pitch down, bang roll left and right, and also yaw. The thrust levers and the stabilizer trim position. You can see also here the flight controls here, the vertical tail and the horizontal tail around the center of gravity. You can see these components. So this is a little bit of the flight control. I will show you inside the airplane what I mean, and make you an engine start demonstration and flight the aircraft. So as you can see, we have also the control column and stick here, the yoke. This is what we use for flying this airplane after we advance the thrust levers. So again, you can see that I'm using this side stick for actuating the flight controls inside the cockpit, as you can see, which is the Logitech Extreme 3D. So you can see a proportional movement between the side stick and the yoke of the Boeing airplane, and also the rudder pedals. So you climb, you descend, and bang roll left and right. and also the rudder pedals. So this is a little bit of the flight controls. You can have them also displayed over here in this display. I will show you now. You have also this display. Um, it shows some of the Boeing 777 systems. So we have display, we have the engine, we have the status. We need to turn on the APU. We have the synoptics here, so we have the flight controls. You can see the flight controls I'm using now. You can see if I extend the spin brake, the speed brake will be also displayed over here. And you can see when I'm moving the control stick here, you can see the movement over here in this surface area here. So you can see the stabilizer trim and some other factors. You can see the flight controls of the airplane that I show you in the wings of the airplane in detail. You can see this is normal and I can use them. So I'm gonna show you a few more systems. You can see the doors now are closed and the cabin can be pressurized. The landing gear here, you can see the temperature of the brakes and the pressure inside the tires. You can see the electrical system. We have the left engine drive and alternators here, the left drive and the right engine drive for the alternate current. And we also have the backup generators. This is the electrical system, the battery voltage, the APU and the contactor. So a couple more systems. We have the hydraulics here, left engine and right engine drive and hydraulic system. You can see the PSI, the 1000 pounds per square inch of pressure. We use this for flight control, for landing gear and other systems. You can see the systems consumers, the demand and the drive of the engine or the electric backup. So we have also the fuel tanks, the left wing and the right wing fuel tanks, the fuel flow into the engines, the total fuel quantity, the cockpit is closed and the center tank is empty. We have fuel only in the left and the right wing and the total fuel. The air systems here, you can see the left engine and the right engine. The APU is off right now. We're gonna turn on the APU. You can see the duct pressure from the left and the right engine. We use this pressurized air. As you can see, this air system for cabin pressurization, for hydraulic fluid pressurization, for wing and engine on the ice, and for air conditioning. So you can see the temperature. We also use this pressurized air from the APU over here and this line of starting the engines. For the engine start, we use it as a back pressure over here for the left engine and here for the right engine. So you will see the duct pressure here. So if I move the thrust levers here forward, you will see the duct pressure increase from the outflow valve, because it's from the pressurized system of the engine intake. So from the 5th and the 9th stage of the engine. So we have the flight controls again that I showed you before. You can see again the flight controls and also a couple more. We have the checklist. So this is the normal menu before start. For instance, what we need to do before start the aircraft. We have the normal menu. The checklist here is complete, as you can see. So we have also the normal menu. We have the failures if we have some emergencies. So we go back. Also the communication, the engines and the status that I told you. So we're gonna use this. We're gonna start the APU now. The auxiliary is more turbine here. So I'm going here in this overhead upper panel. So this is the overhead part. This is another view of the airplane cockpit. So you can see the same kind of instruments here. This is the flap position. I'm gonna set the flaps up for takeoff here at 15 degrees, so it will display here 15 degrees. So you can see the stabilizer trim here, the fuel flow, also here for the engine fuel control, left and right engine, the speed brakes also. You can see maybe better display here of the system, more clear display. So you can see if I move the thrust levers again forward, it will disarm. So I'm coming over here, you can see we have the flight control computers over here, primary flight control computers. We have the air data inertial reference unit, I will talk to you about later, the thrust asymmetry, the electrical, the battery. We have the APU, we need to turn on the auxiliary power unit. So we have the left engine and the right engine drives alternate current. So we have from the engine, we have alternate current and direct current. So no, we have direct current from the batteries. So from the engine we have the electromagnetic alternators, 150 volts, 200 volts, 400 Hz frequency, alternate current, about 120,000 kilovolts or 100,000 watts from each engine, which is created from electromagnetic alternators using bipolar north and south pole electromagnetic induction alternator. So we have the backup generators also in the electrical system. We have the hydraulic system, the left and right engine hydraulic pumps also driving from the engine side. I showed you before in the screen. We have the wing and engine at the eyes. We have the fuel tanks in the overhead panel. The engine start, the electronic engine control, and the cabin pressurization and the pressurized air system from the engine and from the APU for starting the engine, for instance. So I will show you now some of the systems. Now the APU must be started. So you can see we can turn off this and we connect the left and the right engine, the window shield here. So we have also the hydraulic, as you can see. We can turn off and on all these pumps here, but we leave them on for now. We have the windshield wipers, the lighting of the aircraft inside and outside, the wing and engine at the eyes, the electronic engine control. We can start the engine with in the auto start system or manually. So if we turn this off, we have the cargo fire, the rammer turbine, the left wing and the right wing and the center tank and the crossfeed for the engine. This is the fuel system with the fuel quantity, and we can dump fuel in flight or jet fuel. So we have the pressurization, automatic, manual, select whatever we like. For climb or descent, we open and close the outflow valve. For pressurizing the cabin or the pressurizer when you descend, and select a landing altitude. But we have it in the auto right now. So we also have the left engine. I'll show you the bleed air. Left engine, right engine. We have the APU on now, so we can use this pressurized air for starting the engine compressor. We can also pressurize the cabin of the aircraft, the hydraulic fluid pressurization, and also use the bleed air and the air conditioning here and ventilation, and also the wing and engine at the eyes. Also system uses this hot air. So we have the hydraulics also here. So this is some of the systems over here. I'm coming now for starting the engines. So maybe I need to come this in this view. I will show you now how to turn off the engines. We turn off using this fuel control switches here. So you will see the engines going down. We have the engine shut down now. Engine shut down. The thrust is decreased. The into the fuel flow, the oil pressure. So if we come here in the outside view, you will see also in the overhead panel the configurations of the switches. So you see both engines are shut down now. There is a little bit of spin in the turbofans. So we come here, we have the left engine now stopped. So we come inside, we go in the opposite panel and start this switch, the left engine auto start. So we come here, you will see this admits compressed air from the APU, a small turbine that we have in the tail of the aircraft, the auxiliary power unit. So we have the N2 above 30%. We can start the fuel flow. So you can see the left engine starts spinning now. We have the start of the spinning here. It's only compressed air from the APU, it's no fuel yet. So we have the beginning of the spinning, so we can start the fuel flow to the left engine here. So we have the fuel flow in a couple of seconds. So here we have it. The left engine has started. And here we go. We have the spin of the left end. You can see it's increasing and increasing. And here we go. It's ready. So we go in the other we go in this side engine. You can see it's off. So we come again here and we start the right engine drive out start system. So we have again the N1 increases here, also the exhaust gas temperature, the N2, the fuel flow is 0. As you can see, the N2 is above 35%, so we have the spinning from the compressor from the APU. So you can see we have started the auto start system. We can start the fuel flow now into the right engine like this. So the N2 increases, the fuel flow will start in a couple of seconds. And here we go, have fuel flow to the right engine. You can see the spinning. And here we have the right engine on also. So we go back here, we only need a couple more things. I told you we have a couple of things and a few more minutes to go. So we go on the menu, the FMC, we have the model, we have the position initialized, this airport here, Lszh, and the GPS for the Adiru, that inertial reference. You can see set inertial positions. So we go in the route from this airport, Lszh, copy paste back into this airport. Over here, the route of the airplane through runway, using runway 14. We have the departure over here through this runway, trans and also the arrival. Same runway again, trans over here, trans dynamic. So we cancel the discontinuity and we use the fuel calculation and the gross weight of the aircraft, which is 580,000 pounds with 5% fuel reserve. We have a total fuel of 100,000 pounds or 46,000 kilograms. So we use 5%, cost index 100 here percent, and the cruising altitude 35,300. This is the cruise altitude here. We can select whatever we like, no problem with that. So we have the Lszh, we activate and execute. So we have the route. Now we can use the takeoff reference, the flaps 15 degrees, the center of gravity of the aircraft flaps 15 degrees, and the takeoff speed V1, V rotate, and V2. This is the takeoff reference for this weight, gross weight, and this center of gravity, and this runway length. So the aircraft is set now for takeoff. Now we're set for takeoff. We start the aircraft. We can fly the aircraft for a few more minutes. So I'm gonna taxi into the runway. So maybe turn on the lights for takeoff here. You can see where we are. So we start moving to the ground like this. Advance the thrust levers forward. From the parking brakes here. We can use these tillers here for steering the aircraft in the ground. So the runway is open for us for takeoff. So we are aligned. A couple more things. Parking brakes again. So here we are right now. This nice outside view. So you can see here the flight directors, the Lszh localizer. I'm gonna use for landing also. It's everything set for takeoff. And we also have the flight plan here, the radar scan for the ground level. As you can see the terrain in front of us. So we advance the thrust levers forward to have some thrust from the engine for takeoff. Here we use the autopilot, the nav only. And we have the altitude hold also. And the autopilot is not engaged yet. So we advance the thrust levers even forward now and disarm the parking brake. You can go. You can see the runway here that we are located in the airport. So we have like we have the airspeed increases here. You can see we have V1 almost, V2 and V rotate, and we can take off like this. So here we go. So we have a positive rate of climb. Retract the landing gear. Here we have the positive rate of climb. You can see we are 1,500 feet above the ground level. You can see the terrain around us, how fast we climb right now. 2,000 feet above the ground level. So we keep climbing with maximum thrust limit here. So you can see here the airspeed almost 190 knots. We need to decrease the rate of climb a little bit. You can see the stall speed margin here. We're gonna lose our lift ability like that. We are 7,000 feet above the sea level and climb with 2,500 feet, 2,400. Still the most. And this is how it stays for takeoff. This airplane after takeoff. So we can now make a small turn over here. Maybe retract some flaps. We don't need so many flaps. Just for having higher airspeed component. Like 250 now. So we fly now with Mach 0.4 or about 500 kilometers an hour. So this is the runway here again. How we keep gliding. So also you now you have the stall speed again here, the margin. So we need to decrease a little bit the rate of cloud. We use some flaps again. So this is as we climb out. We have the star sign here. This beautiful star sign. So hope you like the Boeing 777. As we climb out from the airport, we're gonna turn towards the lake. You can see the Switzerland. It shows the Boeing the 777 the airplane as we fly with 600 kilometers an hour or 200 meters per second. That's 10,000 feet above the ground level. So we keep climbing. So this is the Boeing 777-300 ERX for the night flight. As we climbing over the lake here. 21,000 feet. You can see the margins here, the stall margin a little bit increased. So we have like we can fly 18 more minutes if we want. We have enough time for this flight. Now about not 18, we have 15 more minutes for this flight actually. So it's enough time for this flight right now. 15 minutes. I believe we're gonna make it. So you can see we crossed 33,000 feet. So we start having the chemtrails now. So this is the chemtrails. We fly with about 600 kilometers an hour over fine Switzerland here. This is the beautiful Switzerland, the Zurich area. And we all find the St. Gallen Lake. And we go down for Germany, the Munich area, the Bayern Munich in Germany. So you can see the frozen vapor from the engine as we always flying over here. So this is our spacecraft for tonight, the Boeing 777-300 ERX. We're gonna level off in a while over here. So maybe I need to go inside again. So we reach the cruise level. This is the cruise level. Flying manually like that. We are fixing down. So we can retract the flaps now and also increase the airspeed. Increase the airspeed and turn back into the airport. So this is the German in front of us, the German Valley, the Bayern Munich and the Bavaria. So we turn back into the airport and we're flying. Hope you like here Germany, the frozen Germany and Switzerland lake as we're going back. So we can, if we want, connect the autopilot in a couple of minutes. We keep having the frozen vapors here. So this is our spacecraft for tonight, the Boeing 777-300 ERX. Going back to our base. So you can see we are flying with about 900 kilometers an hour or 300 meters per second right now. The Switzerland here. So we fly with 900 or 300 meters per second, as you can see, overflying 6,000 meters above the ground level almost. So we have to go back into the cockpit, connect the autopilot now. So I need to use this here direct into this waypoint and execute, and also use this landing reference. So we're gonna be flying direct into our waypoint now. So one more time maybe. So we fly manually again this airplane. We lost some time. Need to go a little bit faster. We have like 11 minutes left, so we are okay with that. So here we are again. Our spacecraft for tonight, the Boeing 777-300 ERX, flying with 900 kilometers an hour or about 300 meters per second. While we're flying here, we go back into the Zurich airport. So we are in a straight here line. Have acceleration rate increase. So use the autopilot. So we need to descend now. This is flight level change indicates the airspeed. Electric, and also use the speed brakes here. So you will see the auto throttle connected. We're going down to this altitude now with less airspeed. So we fly with 900 kilometers an hour right now. We have like 11 minutes for this flight left. So we need to be a little bit faster as we're going down. 32,000 feet, coming closer into the runway. As you can see, the runway is here to the left of us, so we need to keep descending, increase the rate of descent. So this is the flight path angle. $19,000 feet, keep descending. So we have the runway somewhere in here. So we have the river in front of us. We keep descending. We fly with about 800 kilometers an hour right now. 18,000 feet. So we'll fly the Switzerland again. So this is the airport here. We're coming down. We need to disengage the autopilot again. Now we fly manually, decrease the airspeed even further. And use the landing gear here. We have the speed brakes down. So you can see the thrust speed commanded for descent. We have idle thrust, just 10,000, 11,000 feet above the ground level. Keep descending. Flying manually now, the airplane. So we will find the river. You can select here the border localizer mode. This will engage the approach mode if we want for the autoland. So you have the nav with the localizer. So 10,000 feet, we can start turning now. Into the runway, we will select a lower airspeed after that, like for landing. So keep descending, a few more minutes to go. You can also use the flaps here at full to slow down a little bit further as we turn the airplane manually. So we have the speed brakes extended. We start using flaps 7,000 feet above the ground level. So decrease a little bit the rate of descent. We are almost to the desired altitude here as we turn. So here where we are almost. Position now closer into the ground, the river over here. So we have the airport somewhere in front of us. We're just closer and closer into the river. So we have 5 minutes more to go for this flight. We cross the cloud here. We can keep going with the instruments over here. We cross the cloud. You can see the instruments. We are in the right altitude, and we're going for the Lszh localizer. Almost. Italian novel. So we have the Lszh localizer. We have the vertical glide slope. We are in the glide slope, and we need to go to the left for the runway alignment over here to align with the runway heading. Just this, so we are closer into the ground. You can see again here outside, one more time, this view over here. We're much closer now into the runway. So we need just for the landing here. If we come we need to stabilize for approach and landing. So we're gonna cross the river here. So here we have the runway. It's in front of us. We need to increase the rate of descent a little bit. So we have the river again. You can see where we are as we are coming closer into the ground. We have the runway in front. We need only to align a little bit. So you can see we have the Lszh localizer again. We are aligned almost with the runway. We are 2,300 feet above the ground level, 3,600 above the sea level. This is the runway, and this is the horizontal localizer, the runway, the airspeed we select for landing, the flaps, and the stall speed. So this is the reference speed we need to hold for not falling down. So now we are 1,400 feet above the ground level. We keep descent. We are totally aligned now with the runway. We need to turn a little bit to the left, following the Lszh localizer approach here. Here we are, going down to the runway, flying manually, as you can see. Again, the Lszh localizer, the alignment with the runway over here. We need also you can see I'm using the manual input, 1,000 feet. Also the rudder pedals for alignment, because we have a little bit side wing component. So this is a nice alignment here. So here we are, ready, 10, flare, touchdown. We just touched down, so reverse thrust and parking brake. So here we are, full reverse thrust. You can see the outside view. We have made a beautiful landing. So we just landed around runway 14 there in the national airport. You can see we're totally safe. You can see here the nose wheel is safe from the airplane. As you can see, there is no breakage into the wheel. Also, the tires into the nose wheel and the vertical metal component. So you can see also the landing gear is the same. It's completely safe. You can see the nose wheel here. There's no breakage, and the tires here in the back. No breakage in the tires. So we can fly the airplane again if we need. It's completely safe. So that was Thomas Hatsios, the pilot captain behind the Boeing 777-300. Thank you very much for watching. I'll see you next time. Bye bye. Thank you for this flight. Bye. Bye.